Okay, so this is the second part of this video. Let's put it a bit up, Jose. So in number 4, right? We're looking at number 4 now. In number 4, we are told that if AD is equal to CF, sorry, we are required to prove that angle B is equal to angle E. Okay. All right, so at this point, if we look at what is required, okay, they want you to prove that angle B is equal to angle C. Okay. Now there's a way that I can work with angles only. Okay, so if that angle is equal to that, and this angle is equal to that, then this angle has to be equal to that, because the interior angles of a triangle adds up to 180. That's one way of doing it, okay? But because they have told us that this length is equal to that, they actually wanted us to use Pythagoras, not Pythagoras, but congruency, okay? But as I said, if you can actually work it out, you're going with the sum of triangles there. It would be even easier. But as I said, that the information given, it's alluding or is tending to the fact that they want you to use congruency. Okay? So if you had gone in the exam and have calculated it using the angles only, you would have gotten the full 4 marks anyway. Okay? But as I said, for the information given, they want you to work out congruency. So what we're going to do is I'm going to go with, remember in congruency is going to be one of 4 cases. In this case, I'm going to use angle side. So I need to know this length here. So the one triangle, so we're going to say in triangle ABC and triangle FED. Those are the 2 triangles I'm working in. Okay, we know that AD is made up of, so not AD but AC, sorry, is made up of length AD plus DC. Right, as you can see, that's this length. And DF is made up of DC plus CF. Can you see that? However, we know that, okay, that is not equal, but we know that AD is equal to CF. How do we know that? That was given to us. Not so? So if that is equal and that is the same length, so therefore AC has to be equal to DF. Okay, we have just proven that now. Okay? So there's our first side. Then we go and say, okay, there's number 1. Remember, it must be side, angle, side, RHS, or angle, side. Or side, angle, side. One of those I missed. Okay? So then that length is equal. Then, if we look at angle A is equal to angle F. Can you see how these lines are parallel? So alternate angles are equal. So angle A is equal to angle F. So alternate angles. So alternate angles with AB being parallel to FE. Okay? Then, you see this angle here? Angle C1 is alternate to angle D1. Okay? So angle C1 equal to angle D1Y. As we see, it's alternate angles with DE being parallel to BC. Okay? Okay. So as you can see here, this is enough to prove congruency. We name 2 sides and an angle. So we conclude, therefore, triangle ABC, now order is important, is congruent to triangle. There you go. A B is the unmarked and C is the arc. So it has to be F, unmarked, which is E, and then D. What's the case for congruency as I indicated already? It's angle, side, because I use two angles in a side. Okay. So why is order important here? Because then we can say that angle A is equal to angle F, which we knew already. Angle B is equal to angle E. That's what they want. So, therefore, angle B is equal to angle E. And what's your reason here? Is that triangle ABC is congruent to triangle FED. Okay. There we just proven what they wanted from us. Okay. Let's look at number 5. Okay, number 5. The question says, where's number 5? Yeah. Here we are told that ST is equal to ER. ER. ST is equal to ER. Okay. Then the question says, so in number 1, we're required to prove, so it's an intra-angle, PST, and triangle, TER. So let's go P, ST, and TER. Okay, what can we say? We can say that ST, the first one is ST is equal to ER. Why? That was given to us. It's given equal. Alright. Then angle S is equal to angle T2. Why? Alternate angles. Then T2 is equal to E1. Why? Alternate angles. Can you see that? So we say S1 is equal to angle T2. So alternate angles. And the alternate is lying like that. So it's going to be SP or QP is parallel to TU or TE. The same thing, no? And then we're saying that T2 is equal to E1. Why? So again alternate, but the Z is lying that way now. So it's alternate angles with ST or TS being parallel to DE or ER, whatever. All the same thing. So therefore we can conclude that this angle here is equal to that angle there. So angle S1 is equal to E1. So we need one more, no? Either side or an angle. However, we know that angle T is equal to angle R. Why? Corresponding. You see that F lying here like that. So T1, make two arcs to show that's not different to the previous one we worked with. So angle T1 is equal to angle R. Why? Corresponding angles with ST being parallel to QR. Okay. So is that enough to conclude congruency? Yes. So you say therefore triangle PST is congruent to triangle. So let's go. P was unmarked, so it has to be T. S is a one arc, so it's E. Yes, so yes, that order is right. And the case for congruency is angle, side. Two angles in the side I've used there. Okay. Then they are speaking with regards to, the question is to work out, is to show that PT is equal to TR. But if you look at this here, there's also a reason why the order is important. We know that PS is equal to TE. We know that ST is equal to ER. And that's what I want. No, PT is equal to TR. And that's actually what I want. So for number 2, this is how we answer it. We then say that PT is equal to TR. Why? Because the triangle PST is congruent to triangle TER. And that is enough to conclude that they are equal. Okay.